Have you ever wondered how much we truly know about our Earth's atmosphere and the changes it is going through? It's a question that piques our curiosity, isn't it? Our atmosphere, an invisible yet vital blanket, shields us, nurtures us, and yet is undergoing significant alterations. Understanding these changes, their causes, and their implications is not just a matter of academic interest, but a pressing necessity for our survival. But how do we probe into something so vast and elusive? The answer lies beyond our planet, in the vast expanse of space. From that vantage point, we can observe our world in ways that are impossible from the ground. Space observations provide us with critical data on trends in ozone depletion, air pollution, and greenhouse gas concentrations. This information is invaluable in shaping our responses to these atmospheric changes. Unraveling these atmospheric mysteries is not an easy task, but with the help of space observations, we are getting closer. Our Earth's atmosphere didn't always look as it does today. In the beginning, some 4.5 billion years ago, our planet was a hot, molten mass. As it began to cool, volcanoes erupted, releasing steam, carbon dioxide, and nitrogen, which formed the primordial atmosphere. Around 2.5 billion years ago, a significant event changed the course of Earth's atmospheric history, the Great Oxygenation Event. This was caused by cyanobacteria, tiny organisms that released oxygen as a byproduct of photosynthesis. This influx of oxygen was a game changer. It allowed for the evolution of more complex organisms and forever altered the course of life on Earth. As the eons rolled on, Earth experienced periods of extreme cold, known as ice ages. These were times when large portions of Earth's surface were covered in ice sheets. The atmosphere during these chilly epochs had lower levels of carbon dioxide, which led to a cooler global climate. Fast forward to about 1,000 years ago and we see the emergence of human civilizations. With the advent of agriculture, humans began to impact the atmosphere, albeit on a smaller scale. They cleared forests for farming land, altering the balance of carbon dioxide in the process. But the real game changer came with the Industrial Revolution in the 18th and 19th centuries. Humans began to burn fossil fuels on a massive scale, releasing vast amounts of carbon dioxide into the atmosphere. This marked the beginning of a significant increase in greenhouse gases. Along the way, humans made key discoveries about our atmosphere. We identified different layers, each with its own unique properties. The troposphere, where weather occurs. The stratosphere, home to the ozone layer that protects us from harmful solar radiation. The mesosphere, where meteors burn up. The thermosphere, where the northern and southern lights occur. And the exosphere, the final frontier before space. The Industrial Revolution marked a significant turning point, leading to an increase in greenhouse gases and heralding a new era of atmospheric change. As we journey forward, we must remember our past and strive to understand and protect our atmosphere, the precious shield that sustains life on our beautiful planet. Space, the final frontier, provides us with a unique vantage point to observe these changes. Satellites, our silent observers circling the globe, are constantly monitoring the Earth's atmosphere. They offer us a comprehensive view of the intricate patterns of atmospheric changes which are often invisible from the ground. These high-tech tools capture critical data on various atmospheric elements. They observe the ozone layer, tracking its depletion over time, and monitor the levels of air pollution across different regions, helping us understand the spatial distribution and intensity of pollutants. Moreover, satellites play a crucial role in tracking greenhouse gases. They measure the concentrations of carbon dioxide, methane, and other gases, providing us with a detailed snapshot of our planet's health. The data gathered from these space observations is crucial in developing effective environmental policies and in planning strategies to combat climate change. Space observations have become our eyes in the sky, providing us with invaluable data on our changing atmosphere. These changes in our atmosphere have far-reaching impacts. They act as silent catalysts, subtly but surely altering the climate and by extension our lives. Rising temperatures, melting ice caps, and shifting weather patterns are just the tip of the proverbial iceberg. But this isn't just about climate. These atmospheric shifts also influence policy. Governments, corporations, and organizations worldwide are now compelled to respond. The data gathered from space observations is instrumental in shaping these responses. These policies, informed by a bird's-eye view of Earth's atmosphere, enable us to take targeted action. They help us tread lightly on our planet, mitigating further damage to our atmosphere. Our actions today will determine the future of our Earth's atmosphere, and space observations are key in guiding these actions. With such knowledge, we are better equipped to make decisions that favor the health of our planet.